It is dangerous to work on HVAC systems without knowledge of electrical circuits and refrigeration systems. Working with electricity and high-pressure refrigerant can cause serious injury or even death. If you are interested in practicing HVAC, take courses taught by a professional or train in the field with a professional.
Hey guys, thanks for checking out my Raw HVAC channel. So if you're looking at this video, you had an issue with your evap motor, meaning you put it on and it just didn't turn on. There's 4 things that can cause an evap motor to not run. Number 1 is no high voltage. Number 2 is a loss of control voltage or low voltage. Number 3 is your start component, like your relays or contacts. And number 4 is a bad motor. So we can check if we have high voltage and low voltage at the same time by doing something simple. You set your system to the off position, fan to auto. And we're gonna pop off the T-stat. Most of them are pretty easy, they come right off. With a little pull like so. And then we're gonna look at our wires here. This is your control voltage, or your low voltage is what you're gonna find here. So we're gonna get our meter. I'm gonna put it on voltage. So you're gonna check with your meter between red or R and any other terminal. And you should get at least 24 volts or around there. You know, sometimes you have 23, 27. You can see I have 28 here. That's fine. That tells me 2 things. I have high voltage and I have low voltage. So I knocked out 2 of the issues in one shot right here just by checking between 2 terminals here. All right. So let's say you don't have 24 volts here at the thermostat. Now what? What does that tell us? That tells us that you either do not have high voltage, or your safety is breaking your control voltage, or you just have no control voltage. So let's take a look. So the simplest and most obvious thing to check first if you don't have low voltage or control voltage is your safeties. Some units just don't have any safeties. So that'll tell you right away, okay, the problem is not a safety. But when you have a float switch, for example, which cuts off your unit if the pipe gets clogged so that you don't leak everywhere. If you got a float switch, that's the first thing you want to check. Check that there's no water in there. Be careful with them. You see here, no water. You know, this would be full of water pushing this little device up, cutting the unit off. But you know, if there's no water, this thing ain't even wet, that's not your problem. That's not what's breaking your control voltage. You should always turn your unit off when taking this out, okay? Because it can cause a problem. If you turn it on and off quickly, it can cause an issue outside. Okay, so if it's not our safety, breaking our control voltage, then we have to open the panel and start looking inside. Most units will have a service disconnect or a breaker on the air handler itself so that you can de-energize the unit before you start messing with anything in there. So that's the first thing you're gonna do, is de-energize the unit. That's where your power comes in. All right, so we got our cover off. Your power's off. And we're gonna go to where our main voltage comes in, which is always the breaker here. You can see the 2 main lines. On a normal unit will have 208 or 240 voltage. That is an average unit. Just about every home has the same voltage. All right, and you check between the 2 lines. I'm gonna show you. And this will tell you, do we have high voltage coming in or not? And if you do, great, we'll continue. And if you don't, I'll tell you what to do. All right, so we're gonna put our meter on voltage. We're gonna come to the incoming high voltage. And we're gonna check between the 2 terminals on top or on the bottom, wherever the power's coming in. And you see here I have 240. All right, you can have 208, 240. That's the average voltage. So that tells us we have high voltage coming in. So if you don't have high voltage coming in, most likely your breaker is tripped. So you got to locate your breaker for your air handler. You usually have a breaker for your air handler and one for your condenser. So here we have our breakers right here. All right, labeled. So I got my air handler, my compressor right here. So I have voltage, so it's not tripped. But if you do not have voltage there, most likely it's either tripped or the breaker is bad. Okay, if you don't know about breakers, I'll make a video on breakers. So if you do have high voltage coming in, but you still don't have control voltage, even with this on, you still don't have control voltage in your unit, then you might have a problem with your transformer. Let's take a look. So this is the best shot I can get of this transformer. But basically you'll have your high side and your low side. This is what separates your high voltage and your low voltage. So I mean, you should be familiar with this if you're doing this. But we're gonna, since we know we have our high voltage coming into our transformer, we can check between the two terminals of the high voltage, which is on this one is the top two terminals. You can see this one is a common and 240 volts, which is what we have here. And it used to have a terminal in the middle for 208, so it's a multi-tap. So you'll have transformers that have multi-taps, meaning it could be for 120, 208, 460. So you have to check your voltage rating to see if it's tapped correctly. Then the other two terminals at the bottom, let's see if I can get it closer here. That's your 24 volts. You can kind of see it right there next to the blue wire. It says 24 volts. And usually your red wire is the one feeding out. It's not DC, but it's directional. It really does have, one is a common and one is the voltage. But if you check between those two, you should have at least 24 volts. If you don't, and you have high voltage, then your transformer is bad and needs to be replaced. So if you checked and you have high voltage coming into the transformer and low voltage coming out of the transformer, then your problem is not here. You got to keep going. So most fans are activated by the thermostat that activates a relay. Here's our relay here. It happens to be on a board. Sometimes you just have a relay, but this one has a board and the little relay on it. It's still the same thing. It's just the board does other, speed things and stuff like that. But in reality, all you're doing is applying power to it through this relay. I have videos on relays too and contactors. You have to be getting control voltage to your relay at the terminals, and if the relay's not closing, the relay's bad. So what if you have your high voltage or low voltage, but you're not getting your control voltage to your relay? Well, what's supposed to send control voltage to your relay is your thermostat. Okay, so if you have that thermostat on the on position and you're not getting voltage to your relay, your thermostat is bad and needs to be replaced. So we checked and we have high voltage, low voltage. Our relay is closing, but our motor still is not running. The next step would be checking the capacitor. If you have a capacitor in your evap fan, that would be the next step. So let's do that. Now, if you're kind of new to AC, remember that capacitors store voltage. That's their job. So even when you de-energize the unit, it takes a while for that voltage to bleed out from that capacitor. So that's why you have rubber over it and things like that, because you can't get comfortable with them. You need to de-energize them. If you don't know much about capacitors, don't mess with them. Check out my video on capacitors. So finally we have high voltage, low voltage. Our thermostat is calling our relay. Power's getting to the motor. The capacitor is good, but that fan still doesn't run. You got to replace the motor. That motor's bad. Check out my video on replacing evap motors.